All right, so we have talked about LCM before, and so what we're doing today is called LCM Method, right? We actually already stamped that in our planners of all places. And so I want to restamp this because being able to find the least common multiple is very crucial for the work that we do today. And so for least common multiple, we're going to keep it simple. It is the lowest multiple that 2 or more, we're going to put in parentheses, values have in common. The lowest multiple that 2 or more values have in common. Again, we've worked with this before. If you're ever not sure on an LCM, just like start counting by the numbers, list them out. And so the reason that this is so important today is because now, once you've got this, flip your notes and look at example 1. Okay. I told you this. I don't like working with fractions. I would love to avoid this if possible. But in order to see the power and honestly the appeal of this approach, I'm actually going to do this 2 ways. And so for example 1, I'm going to solve this as we may if we had come across it honestly like yesterday or even maybe the day before. Okay. I know, and actually I'm going to name this. This is going to be method 1. I know that if I come across a problem like this, I've got constants and I've got fractions. And so to me right now, I know that I'm going to need to move that 3 term. If I'm trying to isolate x, I need to move 3. Moving 3 does me no good right now because I have 1/2. And so I'm going to change the way that 3 looks so that I can have it interact with 1/2. Okay, well then I know that this is really negative 4 over 5x plus not 3, but rather 6 over 2. And then this is going to be equal to 1/2. Question? What did we do to get 6 over 3? And so if I'm thinking about how to change 3 to something over 2, I'm going to take, okay, this is really 3 over 1 times some fraction, I don't know what it is right now, to be equal to something over 2. And so I use my denominators to help me. 1 times whatever this is needs to be 2. Oh, well then this has to be a 2, right? Because 1 times 2 is the only thing to get us to 2. When I do that, whatever the denominator is, the numerator has to match it. And so if this denominator is 2, this numerator also has to be 2. And so I'm going to get 3 times 2 for 6, for 6 over 2. Move on. Yeah. Okay. I've changed this, and so now I can end up subtracting the 6 over 2 from both sides. Okay, well, 1/2 minus 6/2, remember that our denominators do not change. We're going to get negative 4/5 x minus, apologies, not minus, equals, negative 4/5 x equals now negative 5/2. Negative 4/5 x is equal to negative 5/2. Now, we just saw this on the do now. From here, I can either divide by negative 4/5 or multiply by negative 5/4. Remember that they are the same step. And so on both sides, I'm going to have negative 5/4 being multiplied. Now, help me out. Everybody, a negative times a negative is a? Good. And so on both sides of my equal sign, I'm going to end up with positive values. On the left, 5 times 4, that's 20, and 4 times 5, well, it's also 20. And so I'm going to end up with 20 over 20x, which is equal to, okay, 25 over 8. So on the right, yeah, I'll slow it down. We are just multiplying fractions. We know that we have a negative times a negative. We've already named it that's a positive. And so now we have 5 times 5 for 25. And we have 2 times 4 for 8. Remember that we multiply left to right. And so all I'm doing is multiplying my numerators, and then I multiply my denominators. Money.
I don't know if you just said this, but where do you get a negative 5/4?
The negative 5/4 comes from multiplying by the reciprocal of my negative 4/5. So in order to get rid of that fraction, I need to multiply by its reciprocal. And I actually left this step in because I can see that it's going to work now. Because everybody, what's 20 divided by 20? 1. Good. That's what I need. If I'm looking to isolate x, I need to get just one x. And so this is going to end up being x is equal to 25 over 8. Now, I can already sense that we are not maybe a huge fan of what we just did. And so this is why I honestly love what we're going over today, because it makes it so much easier. It makes it so much easier. So if you're looking at this going, I don't know, that's okay. I now want to show you the method that we're going to see today. And so I know obviously you can't do this. I'm just going to move this up. I'm going to put a dotted line underneath here. And we're going to look at method 2. Now, again, method 1 is like multiplying by the reciprocal. It's a lot of fraction work. You saw that I had to change some of the fractions on how they looked, get a common denominator, deal with that. Too much. It's too much. I don't want to do it. And so the other method for this, if I bring this down, I'm just going to rewrite the problem. So we have negative 4/5 x plus 3 is equal to 1/2. All right, this is the original equation. My second method says, actually, just find the least common multiple of your denominators. Start by doing that. And so my denominators right now, I have 5 and I have 2. Raise your hand. What is the least common multiple between 5 and 2? Good morning. 10. Okay. And so if I'm looking for the LCM, remember this is between 5 and 2, I'm going to be using 10. And so what the method we look at today says is, oh, well, if you know what the least common multiple is, actually just multiply both sides by the least common multiple. Because what's going to end up happening is we actually just get rid of all of the fractions this way. And so I'm going to multiply by 10 on the left, and I'm going to multiply by 10 on the right. And so I'm going to have a 10 and a 10. Now, I'm putting the original equation in parentheses because I essentially have to now distribute this 10. On the left, it needs to go to the 4 and to the 3. On the right, it needs to go to the 1. When we do this, you only multiply to the numerators. When we do this, we only multiply to the numerators. And so what we end up with is negative 40 over 5x plus 30 is equal to 10 over 2. Again, all I've done is just multiply that 10 through. Again, the reason I prefer this is because now let's actually look at our fractions. Okay, I have negative 40 over 5. Well, raise your hand. What is 40 divided by 5? Come here. 8. And this is really negative 8x plus 30 is equal to, well, now I have 10 over 2. Raise your hand again. What's 10 divided by 2? 5. And so just like that, I actually just don't have fractions anymore. They're just gone. And now I have what I think is an easier equation to deal with, and frankly looks more like what we've been doing. And so from here, we know these steps. Okay, I've got negative 8x plus 30 equals 5. I'm going to subtract the 30 from both sides. Negative 8x is equal to negative 25. Divide by negative 8. Everybody, a negative divided by a negative is a? Good. And so I'm really going to have x is equal to 25 over 8. Do my answers match? Yeah. And so, honest question. Actually, I'm going to leave this zoomed in for this. Do we think method 1 is easier, or do we think method 2 is easier? Okay, awesome. I love that we're on the same page. What I'll say is, like, if you really prefer method 1, for today, I want you to try method 2, and if you still really don't like it, you can go back. However, I truly think that method 2 is way nicer because you just kill all the fractions at once. Because again, why deal with them when you just don't have to? Johnny, question? Yeah, so if we're thinking of at least common multiple, if we're ever not sure, I'm going to take the two numbers. Now again, these are the two denominators. And so if I have more than two fractions, I need more than two numbers here. But then we just list them out. And so I've got 5, 10, 15, 20, 2, 4, 6, 8, 10, 12, 14. 10 is that number that shows up first in both lists. Good questions. Any others right now? Okay, then we're going to go right on through. I want to now look at example 2. We are not going to split it up. We are just going to do this method. Now, there's more going on. There is more going on. However, the premise of this does not change. And so I know that if I'm now using the method 2, or that least common multiple method, well, spoiler alert, what do I have to find? The least common multiple. Now, somebody, you can just say it. What is one of my denominators?
2.
2. What's the other one?
8.
8. So the least common multiple needs to be between 2 and 8. And so I'm going to have 2. And I'm going to write it out. I know some of us are there. That's okay. 2, 4, 6, 8, 10, 12. For 8, 8, 16, 24, 32. If I look, wait a second, they both have 8. And so my LCM is going to be 8. Now, based on what you just saw me do, once I have my LCM, raise your hand. What should I do with it? Gianni. I'm going to multiply both sides. I'm going to multiply both sides by this 8. So I'm going to put parentheses around my equation. 8 goes on either side. And now I'm going to distribute. On the left goes to the 1 and to the 6. On the right, we go to the negative 2, but then we only go to the 3. This inside set of parentheses, it acts like a blocker. And it says, nope, you actually cannot put anything in here right now. And so instead we go to the value on the outside. Are we okay with that? We'll see. All right. We'll have a few practice problems like this. So from here, let's just multiply it out. So I've got negative 8 over 2x plus 48 is equal to 24 over 8 times 2x minus 32, because again, that has not changed, minus now 16. Again, all I've done is gone through and multiply the 8. All right, I'm going to ask for everybody's help on some of these. Everybody, 8 divided by 2 is 4. Let me get more voices. 8 divided by 2 is
4.
Better. Negative 4x plus 48 is equal to, everybody, 24 divided by 8 is? It's 3. Everybody, 24 divided by 8 is? 3. So we're going to have 3 times 2x minus 32 minus 16. And so again, what started as something with a few fractions in it, my fractions are gone. Fractions are fully gone. This is something almost identical to what we would have seen yesterday. I'm going to distribute. I'm going to combine my like terms. I'm going to start my inverse operations. We did this yesterday. And so, distribute in. Negative 4x plus 48 is equal to 6x minus, raise your hand, or, I mean, I see a lot of calculators that are on desks. Help me out. What is negative 32 times 3? Say it again. Yes, just don't forget your sign. Negative 96. I know I've already gotten written. And then minus 16. Okay, well again, negative 4x plus 48. I haven't done anything with the left-hand side since simplifying that fraction because I just like gotta clean up the right-hand side. Is equal to 6x. Okay, again, raise your hand for this one though. Raise your hand. Negative 96 minus 16. T. Louder. Negative 112. All right, from here, add 4x to both sides. 48 equal to 10x minus 112. Add the 112. Mm-hmm. And so after we clean up this right-hand side, we've like combined the like terms, we've done all of this, I now get to jump into inverse operations. And so, again, we talked about this yesterday. I've got like a lot of starting steps. I generally always opt for trying to make my, I see the bathroom hands, I'll let you know when. I always try and opt to make my variables positive when I can. And so adding the 4x to get a positive 10x. Because I have 10x on that side, I now have to add 112 to get the constant out of there. I'm going to have 160 is equal to 10x. And then from there, you're going to divide both sides by 10 because it's our coefficient. We've already named this. And luckily, this is pretty easy math, right? 160 divided by 10, raise your hand. What should we get, Camry? 16. So x is equal to 16. Now, I'm going to leave this up for a second for two reasons. One, just some processing time. But then two, what questions do we have? Because I know that that feels like a long problem.